We're back with our program that uses a function to draw Winston 4 times. And I've changed it to actually show what age he is at each point of life. And you'll see why soon. But first I need to tell you something about Winston. Winston has an addiction to donuts. He eats 3 of them a day. It's probably why his face is so big and yellow. So to warn Winston about how bad donuts are for him, I want to modify this program to show how many donuts he's eaten total at each point in his life. For example, when he's 2 years old, that means he's eaten 3 times 365 times 2. So 3 in a day times 365 days times 2 years. And we'll just display that underneath that header. So wow, 2,000 donuts. That is a lot of donuts for a 2-year-old. Now, when he's 14 years old, let's see, he's had 3 times 365 times 14, and that is 15,000 donuts. Whew. All right, so I could keep doing this math, but I'm beginning to notice a pattern. I'm repeating my calculation here, and I'm just changing one thing about it, the number of years. Whenever I see repeated code like this, I think to myself, can I make that into a function? Yeah, definitely we can. So let's do that now. I'll define my function up here and call it calc total donuts equals function. And it's going to take one parameter, the number of years, because that's the only thing that we're changing each time we do this calculation. And then inside, we'll do the calculation and save it into a variable. So it'll be 3 times 365 times num years. All right, so now that we have that function, I'm going to replace this expression here with calc total donuts, the call to the function, and passing in 2. Okay, well now we don't see any total at all. Okay, what happened? Well, our function did calculate the total here, but it didn't tell anybody about that total. It's like if a teacher calls on you in class to answer a question and you answer it in your head, but you're too shy to say the answer. You've done the work, but your teacher's never going to know about it. If we want the function to communicate a value to whoever called it, the function has to explicitly return the value. So for a function to return a value, we need to type return, and then whatever it wants to return. Maybe it's a variable or a value or an expression. So here we'll say return total donuts. Okay, so whoever's calling that function is going to get this response. And now our value displays. Yay! And actually, we can shorten our function. We don't even have to store into a variable. We can just take this whole expression here, put it in the return, and then it's just a one-liner. Nice. All right, so now we can go through and calculate the total donuts at each point in life by just calling this function and passing in the number of years. Let's see, it's called total donuts 25. Let's position this correctly. Calc total donuts 65. Okay, wow. So if he makes it to 65, he will eat 70,000 donuts. That is a lot of donuts. I don't think Winston's going to make it. But now that we've made it into a function, it's really easy for us to change parts of it. Like if Winston sees this and says, whoa, that's a lot. What if I just ate 1 a day? Okay, well, we can just go here, change this one number, and see everything change. So that's 23,000. Still a lot. So maybe Winston's like, all right, what if I just had 1 a week? It's like, yeah, that's reasonable, okay. So then we could just change 365 to 50, because there's like 50 weeks in a year, right? Okay, that's a lot better, right? 3,000 donuts. That seems reasonable. All right, so if you see, with functions and return values, we can save code and save lives.